Hello students, today we are going to discuss the first numerical of influence line diagram for bending moment. Question is written as determine the maximum bending moment at a section C distant by 3 meter from support A due to movement of two wheel loads 5 kN and 10 kN 1 meter apart from each other on a span of 10 meter. It means that we need to calculate the maximum bending moment at section C, which is at a distance of 3 meter from support A. Now for finding the maximum bending moment at C, we need to plot the influence line diagram for bending moment at C, and we know that for plotting the influence line diagram for bending moment at C, we need to imagine a hinge at C and we need to lift that hinge by an amount AB by L. So the resulted deflected shape will be the ILD for bending moment at C. So AB by L magnitude will be equals to 3 into 7 by 10. It will be equals to 2.1 because A is equals to 3 and B is equals to 7. Now for the calculation of maximum bending moment at C, we need to place at least one load on this maximum ordinate. So our first possibility is when 5 kN is on C and 10 kN is 1 meter behind it. It means that 5 kN load is placed just above the maximum ordinate, that is 2.1. So for the calculation of maximum bending moment at C, we need to multiply this load with this vertical ordinate. But for the calculation of this x, we need to use the similar triangle property. So it will be equals to 2.1 divided by 3 equals to x divided by 2. We will get the value of x as 1.4 meter. Now for bending moment calculation, we need to multiply the load with the vertical ordinate. It will be equals to 5 into 2.1 plus 10 into 1.4, which is the value of x. On multiplying this, you will get 24.5 kN meter, that is the bending moment at C when 5 kN load is placed at C. Now the second possibility is when 10 kN is on C and 5 kN is 1 meter ahead. It means that in this case we had put the 10 kN load above the 2.1 ordinate. So from similar triangle we can determine the value of x. It will be equals to 2.1 divided by 7 equals to x divided by 6. We will get value of x as 1.8 meter. Now for the calculation of bending moment, we need to multiply this load with this vertical ordinates. Okay, so it will be equals to 10 into 2.1 plus 5 into 1.8, that is 30 kilonewton meter. So maximum bending moment will be equals to 30 kilonewton by second possibility. So we will put the 10 kilonewton load at section C and we will get the maximum bending moment as 30 kilonewton meter. That is all about this question. Thank you very much, students.